Hi, and welcome to the Coolselector deep dive session. My name is Morten, and in this session 4, we'll look upon fittings. So let's turn the flip over. First of all, when we say fittings, we generally talk about pipe bends, expanders, and pipe reducers. So things that make our piping system connect. When we did the pipes, we had an equation called the Darcy-Weisbach equation. And if we remember back, it went like this. You have the head loss, and let's call it pipe. It's equal to a friction factor times the pipe length over the diameter, velocity squared, halved. So that was the head loss. The head loss we want to put into our energy equation to find the pressure drop. The L over D, the length, is normally quite limited for fittings, and also the diameter. And the friction factor is certainly something that is slightly different from the equations we went through last time. But we can reuse the idea. So instead of this term, for fittings, we'll talk about a resistance coefficient, and normally use the Greek word or the Greek letter zeta for this. So the resistance coefficient, and again, times the velocity squared, halved. So we went from some head loss, and now we have a resistance coefficient. So now how do you get hold of this? In Coolselector, we use different sources for this. One of the most important sources we use is a book by a guy called Miller called Internal Flow Systems, where you will find resistance coefficients for different pipe bends, different fittings, expanders, reducers, all the things you need. And those we have put into equations and entered into Coolselector. So you don't have to worry about finding the resistance coefficients. Also, when we talked about pipes, we talked about both compressible and incompressible flow. For fittings, they will normally be of so short distance that the density will not really change in the fitting. So we use this equation more or less for both compressible and incompressible flow. If we write the pressure drop for this, you'll get that the pressure drop, or equal to P1 minus P2, is equal to density squared halved. So this concludes the fitting part. Now we can calculate everything we need to know. Next time we'll look upon valves, and we'll continue using the head loss equations and finding head loss for different types of valves for compressible and incompressible flow. Until then, you can download Coolselector from our homepage. Thank you for watching.